spontaneous emission and Einstein A coefficients. Here I have written Einstein A coefficients. Actually there are three coefficients related to the quantum phenomena spontaneous emission, A, B and B dash. So three coefficients are there. Here in this video lecture I am talking about only A coefficients. Okay. Here this coefficient A is related to only emission process. Okay. So spontaneous emission, this is a quantum phenomena observed in the field of quantum mechanics. When an atom or a molecule absorbs light or heat energy, it transitions to a higher energy state. Means electrons of the atom or the molecule reach to a higher energy state, higher energy level. Okay. And then there is a spontaneous process by which photons are released from the atom or the molecule, and that process is called spontaneous emission, because here in this case no force is applied for the process. Okay, for the process of emission no force is applied, since this process happens spontaneously without the influence of any excitation or force. That's why this is called spontaneous emission. And in the context of this spontaneous emission, there is one coefficient that is called Einstein A coefficient. So there are three steps in the process of spontaneous emission. First, it is excitation, then it is emission process, last one is photon emission, second one is spontaneous emission, and the first one is excitation. So the first step, excitation, that means when light or heat rays incident upon atoms or molecules, then in that case atoms or molecules reach to a state of higher energy level. Means here atoms or the molecules absorb the incident light or the heat rays. Okay, means actually electromagnetic rays. I am talking about electromagnetic rays here. Okay, so this is the first step, that is excitation. Means atoms or the molecules are excited just on receiving energy. Then second is it is emission, spontaneous emission. So when an atom or a molecule is in excited state, there is a spontaneous process by which it releases that absorbed photons. Okay. So this is called spontaneous emission. Here no force is being applied, or there is no other influence which is being used for the emission process. So that is why this is called spontaneous emission. And when in an excited state, it actually receives or absorbs photons in the form of light or heat rays. Last one is what? Photon emission. So when an atom or a molecule is in an excited state, it releases photons. Okay. This release is spontaneous, and the energy carried by the photons is equal to the differences in the energy levels of the atom or the molecule. At higher energy level or the excited level, energy is more, and in the lower energy level or lower energy state, energy is less. So this higher energy minus lower energy, that is equal to the energy carried by the photon during spontaneous emission. So this quantum phenomena is of crucial importance in the field of quantum mechanics, especially in the case of lasers, and many other things are there. Wherever there is a case of spontaneous emission, there is the importance of, you will find the importance of few coefficients are there, which is called Einstein coefficients. There are actually three coefficients, A, B and B dash. Here we are talking about only emission, so our requirement is to use Einstein A coefficients. Capital A is used. Okay, capital A is used for writing Einstein A coefficients. So Einstein A coefficients, this is used in the context of spontaneous emission. Okay, so that's all about the spontaneous emission and Einstein A coefficients. Okay, so this is the end of this video. Thank you. Thank you for watching this video. Later I will make videos on other coefficients, Einstein B coefficients and Einstein B dash coefficients. Okay. In this video only, I talked about Einstein A coefficients. Thank you. Thank you once again.